Welcome everyone to Tetrate Tech Talks, a weekly live stream where we feature a conversation with a guest to discuss technology and do technical demonstrations and more. My name is Eitan Suez. I would like to welcome everyone to our live stream. This is episode 5, discussing WebAssembly with Brian Sletten. My name is Eitan Suez. I'm coming to you live from Austin, Texas. We're broadcasting on YouTube and LinkedIn Live. Tetrate is the enterprise service mesh company. I am Tetrad, and much of our focus is on service meshes, Istio, Envoy, Kubernetes, and other technologies, but we won't shy away from topics that are further afield. There's plenty to talk about, and I think this episode is very apropos as we're going to explore WebAssembly. Maybe even beyond the scope of service meshes with our guest. So I would like to remind everyone about our landing page, which you see right here, the Tetrate Tech Talks landing page, which contains all of the links, by the way, that we're going to be covering in this episode and in past episodes. So there's only one link to rule them all, so to speak, and from there you can get to the page that describes the episode, as I'm about to do, and you'll have access to all the resources that we discuss. All right, so as I make this page a little bit bigger, what I'd like to do is begin the episode as we do usually with announcements. Today is May 6, 2022, 9 a.m. Pacific, noon Eastern. We're on episode 5, and our guest is Brian. He's with me waiting in the wings. I'll bring him on in just a minute. So the Tech Talks, if you're new, I would like to welcome you. If you're a repeat visitor, I would like to say thank you for listening in and continuing to listen in. These are a series of broadcasts we run weekly, although we had one exception last week due to the Istio conference. And the objective is learning, sharing knowledge, getting to know the members of the community, and above all, to have lots of fun in the process. The episodes typically present a technical topic and or feature a guest. I'm your host, Eitan Suez. And I would like to invite you, if you're live with us, to say hello in the comments. Just put a message in, say, hi, I'm so-and-so from whatever location you come from. That usually is customary, and it's wonderful to sort of know who is with us. So I appreciate that. So a quick recap of some of our previous episodes. Our last episode was 2 weeks ago on April 22nd, where we had Lucas Ponce from the Kiali project come on and give us a compelling presentation of the Kiali console for Istio, and that you can catch all of our episodes on our YouTube playlist of the same name, Tetrate Tech Talks. And as far as event recaps, the big event that took place last week, all week long, was IstioCon 2022. That happened. And just to give you a brief summary of the conference, it was an online conference. Eric Brewer gave a keynote presentation. Eric Brewer from Cap Theory fame. He spoke about zero trust architectures with service meshes and how they apply that at Google. The big announcement of the conference was that Istio has applied to join the Cloud Native Computing Foundation. You can find the announcement here on this page. And that's generated a lot of excitement. We're at Tetrate also very excited. Our CEO, Varun, has also published a blog post on the Tetrate blog on this subject. Peter and I at the conference also delivered our workshop, Istio 0 to 60, which was very well received, and I appreciate everyone who attended. And I see Chino says hi from India. Hi, Chino. Thanks for joining us. One of the sessions from the Istio conference that I'd like to call out, which is relevant to the subject that we're going to talk about today, is a talk that was co-delivered by another Tetrad. Let me go ahead and pull it up. Takeshi Yoneda, who is also the author of the Proxy Wasm Go SDK and some other Wasm-related projects. I think this one was an apropos one to highlight for our talk today, for our episode. Also, you should know that Istio channel on YouTube has a playlist for all of the session recordings that took place at the conference. You can see here on this page that those recordings are probably still in the process of being edited. And in the meantime, if you've registered, or if you can, I think post facto can still register, you can go to the Crowdcast page and visit and view all of the recordings from the conference. So wanted to point that out for everyone. So that's just a brief, quick summary, highlights of IstioCon that took place last week. And this is a busy time of year for all of us, as the upcoming events. Where I think KubeCon EU and Service MeshCon are upon us. They're taking place the week of May the 16th, which is just 10 days away. In Valencia, Spain, Tetrate is hosting a co-located event, which I'd like to emphasize here. We call it the Service Mesh Immersion Day. You will actually find it on the schedule for the conference. So if you're registered and you're looking at the schedule for the conference on May 16th, you will see the Tetrate event called Immersion Day. We're going to be running 2 tracks. So basically what I'm trying to say is that the Immersion Day will be really open to people of all kinds of backgrounds. If you don't know Service Mesh, you're welcome. We're going to have a track that's going to be the Academy, the workshops that teach you sort of from the ground up, Envoy, Istio, and WebAssembly. Peter, my colleague, and I will be there sort of conducting that track. And then the other track will have talks from the community and higher level talks for people who have experience with Service Mesh. So there will be something for everyone. On the Tetrate event page, also you should see next week we'll have another Tech Talk episode, of course, and just keep an eye on this page for any upcoming events. All right, so much for announcements, and thank you for bearing with me. I would like to begin to bring on my guest and introduce him. So give me just a second as I shuffle through these layouts here. And Brian Sletten is president of Bosatsu Consulting. He is a consultant, a trainer, and also an author. He recently published the book Webassembly, the Definitive Guide, which definitely caught my eye. I reached out to him a few weeks ago, and I was very happy and delighted, in fact, that he was willing to join us and talk to us about all things WebAssembly and maybe other things beside. I would like to also mention that Brian and I sort of know each other from, I guess, a past life. We both, I used to be briefly a speaker on a conference series called No Fluff, Just Stuff. And Brian has been with that series for the long haul, I believe. And we met, I want to say it's been at least like 2 decades ago. Well, not at least, but at most, yeah. And it's wonderful to see him again. Brian, welcome to the show. I'd like to give you an opportunity to introduce yourself properly.
Sure, thank you. It's an honor to be here. It's good to be back in touch. I always enjoyed our conversations back in the day.
Yeah. So I know, of course, you've written an entire book explaining and exploring WebAssembly, but I figured maybe the best place to start in terms of our conversation on this subject, for the benefit of those who maybe haven't been following the developments in this area, is to perhaps provide some kind of basic definition of WebAssembly as a starting point.
Sure. The community has kind of a common joke that nobody really knows who to attribute it to. That WebAssembly does not involve the web and does not actually involve assembly. But it's a suggestive of enough name that I think it makes sense, and it's I think why it's stuck. It is an attempt to solve some of the major problems that we've had in our industry with respect to delivering value in the form of software in a rapid, safe, and portable way. So we've obviously been promised that many times. The most probably successful version of that would be the Java ecosystem. But these days, Java mostly runs on computers, and we're looking at an ecosystem that's ever more heterogeneous. So phones, tablets, in browser, out of browser, cloud computing environments, edge computing environments. And that involves really a shifting notion of context and a level of trust that we just can't assume, right? So code that has free access to the computer and its resources is clearly a problem in this world of malware and phishing attacks and things like that. So if we're going to run the code in all these different environments, it has to be portable, but it also has to be safe. And so really WebAssembly is an attempt to give us the ability to express, in essence, arbitrary computation. So pick your programming language and run it in any platform and let the platform enforce whatever kinds of permission models that it wants to. So you could think of it as the promise of the Java ecosystem, but with like 20 or 30 years of experience, right? So they're not trying to over specify things. They're not trying to solve problems that really don't need to be solved at this level. And so it's a multi-level, long-term approach through the standards body to create initially a target platform. So the target platform is akin to the JVM in terms of the bytecode. That
right. There's the notion of a virtual machine, right?
A virtual machine.
Yeah.
.NET and other environments have this as well. It runs in a sandbox, and by default, it is a sandbox that does not allow you to leave. You cannot open the file system. You can't interact with network resources. You can't do anything like that unless the environment gives you those abilities. And that seems like a tremendously limiting perspective, but there's a lot of code out there that doesn't need those resources and is still able to then be targeted into these environments. And so it'll run fast, it'll run safely, and it'll run portably. So that's really the idea. A lot of people have the idea that it's really just about getting rid of JavaScript in the browser, which it's not, right? There's nobody in the WebAssembly community really that's advocating to get rid of JavaScript. It's that we are able to get more reuse out of the software that we create, and to do so in a wider number of environments. So there's about 5 or 10 major use cases that WebAssembly supports, and there are new ones coming all the time.
Yeah. I'd like to give a reminder to our audience. If you have questions for Brian, feel free to post them in the chat, and we'll tackle them as well. I've got my little list over here. Another thing I want to maybe clarify for everyone listening is what is the intersection? Why are we interested in Wasm and the service mesh world at Tetrate and people who work with Istio? And that's because that's one niche area where Wasm has found a perfect home, a perfect fit, where the idea was to provide a mechanism for extensibility in Istio and with Envoy to sort of customize the behavior of proxies. And if we have time at the end, we can also explore that, and I can do a quick demo on that if there's such a desire. All right, so I guess my first question to you, Brian, is, and this is something we just touched on maybe last week when we sort of touched base. My sort of angle into this was when I remember on the Fluffduckers list, you posted a message about your upcoming book. I'm holding it right here. I bought it. I was curious, and I started reading it, and by the way, I very much enjoyed it, but I wanted to see if you were interested in sharing with the audience how the idea for this book came about. I'd love for you to share that story.
Sure. So as you mentioned, I tend to talk about next generation technologies or things that maybe have not caught on yet, but I think provide a lot of value. And over the past several years, I'd been focusing more on machine learning and things like that. And in December of 2019, the guy who runs the conference asked me what I wanted to talk about in 2020. And I didn't really have the idea of this big umbrella connected topics, but I wanted to focus on things that I thought maybe had gone off of people's radar or people had missed, and yet they were already providing value. And so I sort of lumped them together into this idea of modern software development, right? As opposed to sort of like our conventional notion of we write software and it runs on computers, but this idea of multi hardware, multi location, heterogeneous computing environments that we have to deal with, and how are we going to handle that? So I called it modern software development, and I just threw a bunch of ideas in there. And we only got one conference off that year because obviously that was when the pandemic hit. Yeah. And it didn't even occur to me until I was giving the talks that weekend how related these ideas were. So, I mean, I had talks about LLVM as a compiler infrastructure that's extensible, that allows you to target different backends from the same front ends. I talked about linked data as a way of making it easy to exchange information with people you've never spoken with before, which is, at odds with the idea of a level 2 REST API where you have to write custom software to consume information. I talked about the role that hardware was starting to have in our environment, in our industry, excuse me. And I talked about WebAssembly. And so as I was giving these talks, I kept on saying, but in the next talk, or the talk that I'm giving tomorrow, or the talk that I gave last time, and by the end of the weekend, I was having this, what I refer to as my beautiful mind moment, where I just had this sort of 12-dimensional model in my head of how all these things worked together. And, it was actually a little unnerving. And I ended up calling up Matt Stein, and just I knew he was up, and was give him a very quick dump of my ideas. And he's like, you should write a book. So that night I just kind of vomited thoughts, into an email and sent it off to Mike Lapides at O'Reilly.
O'Reilly, yeah.
And I expected him to come back and say, whatever,
crazy.
Dude. this is
go back to sleep.
Yeah. But honestly, the next morning I woke up and he had a very thoughtful response, and basically saying, I think there's something here, and we've been talking about emerging technology periodically for a while at this point. And after some more conversations, he said, I don't really know how to turn that into a book, but why don't we start with WebAssembly? And so that's really what kicked off the project. And over time, as I mentioned, I've begun to think about telling the story, because it is so complex and interrelated, a bit like how Marvel has approached the cinematic universe, right? If you look at the fact that there's been 30-something movies now and multiple TV shows and everything, and you go back in time and try to tell somebody that story, it would be impossible, right? But if you look at how they did it, they started with some tentpole properties, right? Iron Man, Thor, right? Characters who had a fan base, characters who were sort of known properties. And then by introducing them and what each character sort of brought to the table, both in terms of strengths and weaknesses, and then you started telling the interplay between the characters, they were able to build the narrative up to the point where they could imagine the Avengers series. You could imagine, spinning off into Black Panther and the multiverse and everything. And so that's kind of the approach that I'm taking, is that I'm thinking about each of these as Iron Man and Thor and the Hulk, and then trying to show how they come together. As a very quick example, right? Rust as a language materially improves the quality of our software, right? Yeah. It moves things from being runtime errors to compile time errors. And so by choosing a language of a particular nature or flavor, you can improve the quality of the software that you write. And it's security, that's everything that comes with that. But Rust is also an LLVM-based language. Therefore, it has always been cross-compilation and capable. And therefore, when WebAssembly emerged, it was easy for them to change their backend.
It's like the puzzle pieces started to fit, just like Marvel. Yeah. I see that.
Exactly, right?
Wow.
So when you use a language that changes what you can do from a quality perspective, and then you build it on the back of an infrastructure that allows you to target multiple backends, including, all these different languages, you start to see that these things make a difference. These aren't just shiny objects that as developers we're chasing because we want to pad our resume. These are technologies that are fundamentally moving the ball down the field. And you have to look no further than Apple's migration from x86 to the M series, right? Which is a shift from Intel to ARM-based CPUs. They did that by hiring Christian Lattner, who created LLVM many years ago, to run their toolchain strategy, shifted away from GCC to LLVM, got all the developer tooling switched over, got all their developers switched over. And so by the time it became ready to target the new platform, at that point, it was just a question of recompiling, at least in that direction, right?
Wow, yeah.
And so it's those benefits, those tangible benefits that help solve things. One of the other things that's going on is hardware is increasingly becoming an important consideration, right? Not just because we now have to target x86 and ARM, but because we're seeing the rise of open source ISAs like RISC-V, which is now enabling different countries and companies around the world to move into the fab worlds, right? So China and India and the European Processor Initiative are all developing their own capabilities, right, at the computational element level. And this is in part due to a trend called IT sovereignty, right? Countries want to be in control of their supply chains, not just because of things like the pandemic, but if you look at like what's going on with the war in Russia or in Ukraine, Russia is now going to have a hard time sourcing components that they need for high technology because of their dependency on other ones. And here in this case, that's a good thing for the world, but countries don't want to have that kind of
provides a strong motivation rooted in economics, the value, and it's not just like you said, a toy project. Yeah.
So if we're going to have all this slight variation in computational capabilities, then we need technologies like LLVM and WebAssembly that mediate those differences in ways that we as developers don't have to worry about them. So, hardware is solving problems, architecture is solving problems, right? The move towards microservices away from monoliths is a remarkable shift when done properly. When architecture is the bottleneck, then this gives us technical and business benefits in terms of how do we parallelize development, how do we get scale at the horizontal and functional and data sharding capabilities, right? But then we also want to distribute these microservices and serverless functions so that they are geographically closer to the clients. And that's where edge computing environments come in. But if we're going to allow people to write arbitrary code to run in edge computing environments, then they have to be sandboxed computing environments, which is why companies like Cloudflare and Fastly and whatnot are so heavily invested now in WebAssembly. And we're seeing the emergence of initiatives like the Bytecode Alliance as industry titans, Intel and Microsoft and ARM and everybody coming together to build secure computing environments at the intersection of WebAssembly and some of its related technologies.
So I guess to some extent, your book is almost like a call to let the community know that major changes are afoot, major innovations are going to happen, and then you give them pointers to all of the different activities and projects that are taking place.
I did the best I could. It's a industry that's changing daily, and I tried to have the book have some
concrete examples.
Right?
Yeah, I see that too. Yeah.
But it is an attempt to do that.
Yeah. So I know that what I want to do is interleave. I know you have a few examples that you want to share with everyone, and I think that would be nice and refreshing for people to actually put the rubber on the road, so to speak, to actually see examples of this in action. So I'm going to switch to a different view over here and add your screen here,
Sure.
and let you demonstrate some of these tools or examples or demos or whatever.
Sure. What I'm about to show you is a series of demos that embrace really sort of the first kind of fundamental use case of WebAssembly, which is running arbitrary code in the browser. Right? It's part of what we refer to as the minimum viable product, and it's based on technology that's roughly 5 years old at this point. They just recently updated the specification to 2.0. But the idea is that this is just the starting point, right? So as I'm showing you this, keep in mind that cloud computing environments and edge computing environments and Internet of Things devices, right? You got companies in Michigan and the auto world, trying to assemble software and hardware systems that are coming from all these different vendors, and they need to communicate and they need to run in safe sandboxed environments. They're going to be very interested in these kinds of technologies as well. And so as cool as what I'm about to show you is, it's just the first step, and there's this entire separate space beyond that. So the first use case is not, let's not use JavaScript. The first use case is, let's not rewrite stuff that we don't need to rewrite, right? This JavaScript in the browser has become an incredibly powerful environment, but there's still a developer activity to migrate existing functionality into JavaScript. So in this first example, the JQ command line tool is a well-used, nicely written, portable C command line tool that if you're using a tool like curl or wget or hdpy to interact with a web resource, you may get some JSON back, and this allows you to pipe the results into like a little query language to extract details from the JSON. So as a tool, it's great. It's useful. And there's absolutely no reason you could not write this tool in JavaScript.
Right.
However, there's no reason to, right? So Robert Abou-Khalil who has a great WebAssembly, a set of WebAssembly resources called Level Up with WebAssembly, and I'll make sure to get you that link as well. Sure. But you can get to it through this JQ Kung Fu thing. He has taken it and he has shown that if you recompile the command line tool and expose the behavior as a WebAssembly module in the browser, we can just tap into it. So here we have some JSON on the left, and the query up here is selecting the first element from the JSON, and the output JSON is on the right. But if I modify this, right, and say grab me all the elements and then grab me the email from all of the elements, he's got this JavaScript-based framework that's calling into the behavior that JQ provides, and it was not something that behavior had to be rewritten in JavaScript, right? So the first use case is just simply, let's not rewrite stuff we don't have to rewrite. It's not because there's a problem with JavaScript. It's just because there's only so much time in the day, right?
Right. And this is compelling, by the way. I mean, it just builds a GUI for a product that never even intended for or thought about that avenue. Yeah.
Yeah. So if we could take command line tools, then a command line tool that I've already mentioned is Clang or Clang, right? Which is the C++ and Objective-C front end or implementation of LLVM. So what I'm showing you right now is a browser environment that has the compiler compiled to WebAssembly. So it's now able to take arbitrary C code while within the browser and compile it into, in this case, a 6 kilobyte binary image.
Wow.
So, I mean, I think I've had Java classes whose names take up more space than that. And then we're now able to run that code in the environment of the browser, because the browser as a computational environment brings a lot to the table. It's got the ability to do hardware accelerated 2D graphics, 3D graphics, sound, interact with the user, etc. And the building process basically routes, for example, OpenGL calls to WebGL calls, or things like that, so that the application does not have to be rewritten, even though it's targeting a different environment, like running within the browser. And that's really what we're trying to do. We're trying to optimize developer productivity and the value that they contribute, and to capture that value for longer, so we don't have to rewrite everything all the time. So just the idea that we can take a compiler, compile it to WebAssembly, and then compile other code in a WebAssembly environment to WebAssembly, it's like there's a stack of turtles in there somewhere, right?
That's really compelling.
So then we can take existing toolkits and frameworks and things like that, and this is just an example of a C++ based user interface that was written in sort of clean portable code, and it interacts with low level capabilities like OpenGL, and it can just simply be recompiled to target an environment like running in the browser, backed by WebGL. So in my book, the second use case here that I'm imagining is really sort of nicely manifested in this work by a guy in the game industry. He created a project called eGUI for an electronic GUI. I'm sorry, like not electronic GUI. Just an immediate mode drawing model in game. Right, so you can have like little components that you can interact with to configure the game elements.
Okay.
But he wrote it in Rust, and he wrote it with the intent of also targeting the browser. So this application is not just necessarily a question of, hey, let's reuse existing code. This is a new approach that says, let's build applications that run both inside and outside the browser, basically without modification. And so his web demo, it's a complex demonstration of the capabilities of the UI, but this looks the same if you just run the desktop version of it as well. So he's got these various demos, of animation and building code editors and what does the code look like, right? So this is his UI toolkit, but it's running within a browser. And it's doing so in a way that allows us to, again, write software that can just very naturally migrate from the desktop into the browser without much additional effort. So that's kind of another use case of what WebAssembly brings to the table.
Wow. So this could append, for example, developers who use like an IDE, for example, the old, I guess I can't believe I'm calling, JetBrains IDE old, but well, it is, but they've always kept up to date. But it totally changes the game for people who, and not just tooling, but
yeah, absolutely. So the next use case that I imagine is the idea that we have existing platforms, right? And these platforms have engines, and the engines themselves can be compiled to WebAssembly. And that's what's going on here. So this is the Unity engine compiled to WebAssembly, and then this is a series of assets known as the Epic Zen Garden, right? Running on top of that. So I think it was like 4 or 5 years ago, Apple used this demonstration to show off the power of their hardware, right? Okay. And now it runs in a browser in a completely cross-platform way. So it'll come across as a little bit janky coming, across the shared video, but in person, it is smooth. There's, beautiful sounds in the background.
Wow.
You can interact with the fish. You can interact with the environment. So in this scenario, if a platform has been moved into this space, then things that run on that platform also will then run in the browser without.
So I guess that means it amplifies by probably at least a factor of magnitude the value of that.
Yeah, and I'll show you some more examples in a moment. But like the Python environment has been compiled through a project called Pyodide and PyScript now, so Python runs in the browser. But this is also then extending these ideas even further, which is, let's not just think about bringing stuff into the browser. Let's think about extending what the browser can do, and take advantage of what's there. And to me, this is one of the most amazing applications of this by Colin Eberhardt. He took an application that used WebRTC. So WebRTC is a W3C standard for peer-to-peer communication, for shared video, shared desktop, shared audio, shared data channels. But it also gives you permission to access to the video camera in the browser. He then took OpenCV, which is a C++ based computer vision library, recompiled it to WebAssembly, ran it in the browser, and then was able to take this Sudoku game that he's holding kind of at an angle and flatten it so it's a straight-on image. He then uses TensorFlow to build a model that does character recognition and identifies the givens in the game. So the black numbers are the givens in the game. Yeah. He then has a representation of that he then hands over to a Rust-based Sudoku solver that was compiled to run in WebAssembly in the browser, solves the game, based on the constraints and the rules, produces a result, and then goes backwards to render the solution in red on the video frame.
Yeah, that's crazy.
And that's a sense of where we're going when we can arbitrarily extend the browser with these additional capabilities. Because up until now, our options were to wait for the W3C member organization.
Right.
I'm a huge fan of the standards process, so don't take this the wrong way. But trying to get 400 organizations or so to agree on what's important is a very, very slow process. And so we have to wait for them to agree on what's important. We have to wait for them to design stuff, and then we have to wait for the browser vendors to implement them. And then we have to wait for the users to upgrade to use the new versions. Mm-hmm. But in this way, we can just simply extend what the browser is able to do and have sort of like these slow migrations towards the new capabilities like audio and video and peer-to-peer communication and whatnot, with the ability to overlay all of this innovation. And you do not have to ask anybody's permission, and you do not have to, get 400 organizations to agree on what's important. We can add things like computer vision libraries and TensorFlow, right?
It's very democratizing, is what you're saying. Yeah, there's no longer a hierarchy. I mean, I guess we both. I mean, almost everyone out there who's been in the technology sphere long enough knows that. Whether it was JavaScript or CSS. I mean, I remember when jQuery, back in the day, changed the game because they started implementing features that you would expected the standards bodies to implement, but they just weren't moving fast enough. Selectors and things like that. Mm-hmm. And this takes it a whole.
And ultimately, this is what we've wanted, right? We've wanted the ability to have safe, fast, and portable code that does not require installation.
Yeah.
But our attempts to get there have involved Java applets and Flash and Silverlight and things like that. And for security reasons, those were always sandboxed. And therefore, they could not participate in the web portion of the web. But now we've unified these worlds. So they are not sandboxed. We're able to emulate memory. We're able to render images into shared memory that we then hand off to edge detection algorithm written in C, and there's just no effort really to tie those things together. So it's the promise of Java without the distractions of AWT and Swing, right? we're leaving the UI as sort of a solved problem, or at least a separate dimensional, a problem to solve in a separate dimension. It's not necessarily tied into the platform itself. And I think that's one of the big problems that Sun faced, and eventually Oracle, was that they tried to change everything, right? Networking and user interfaces.
Everything had to be rewritten. Yeah. And then here you're actually cobbling up existing software through, and then WebAssembly is just, in a sense, just the glue. It's basically a mechanism of bringing these things together. Wow.
Absolutely. And that's one of the things that's also cool about it, is it's not something that you have to commit to like all at once in some kind of big bang integration. You can find places that make sense. So here's what I was saying about Python. Things like Jupyter Notebook have been very popular as a way of telling data narratives in data science activities and whatnot. But because Python historically did not run in the browser, you would have these cells that had text in them, and then the text would be sent to a backend server, and then the results would be streamed back to show. This is Python running in a browser. So we have the concept of cells. I'm executing the cells. I just triggered the loading of the Python plugin. Now my machine's got a lot going on it, so it takes a second. But once it's up and running, it's the Python C engine that has been compiled to WebAssembly, right? So now Python runs, and you'll notice this DOM element called change me here. In addition to being able to create like Python lists of, dictionaries and things, we can also modify the DOM element from the Python code. And so
it goes in both directions. Yes.
Right. And so this has recently been sort of more formalized in an initiative called PyScript, as a way of bringing Python into the browser sort of more formally. But the idea, again, is we can have notebook environments like we've liked in Jupyter Notebooks, but they can be sort of more interactive. And you can imagine the textbooks of the future where, you and I grew up looking at pictures and books, and, kids now can have interactive videos and like change the parameters of physical simulations, as part of their textbook process. And it can be done so in a way that allows, commodity hardware, browser-based technology. There's not a huge buy-in, right? This makes it easier to get into more hands, and technology is less of a, hopefully, discriminator, in terms of helping people of various backgrounds learn and pursue whatever, fields of interest that they want. So there's no installation. There's no concern about you have to buy a particular type of computer. And in theory, you could go to the library and use a browser in the library and access the same information, right? And the same capabilities. So that's what's really exciting to me about these ideas is really where it's going to help take us as an industry.
Let me pause you for just a second, as I noticed that we have someone who posted a question about 5 minutes ago. So let me just parrot it back to you. Or maybe I can show it on the screen. It's a little bit verbose, but let's go ahead and do that. So Sorab is saying, interesting, what about WebAssembly in the plugin development world? I see most plugins are revolving around mostly finite automata algorithms. And WebAssembly seems like a perfect fit for those, specifically things like ad hoc.
No, that's an excellent question, and absolutely that is one of the use cases. I was kind of surprised when I was working on the book to find, how much was being done with like Envoy. So if you want to extend the capability of writing filters and things like that, you can. But even beyond that, I mean, that makes sense kind of in the enterprise space.
Yeah.
But Microsoft is using WebAssembly as the basis of the plugin environment for Microsoft Flight Simulator these days.
Wow.
Right? So as part of allowing people to write extensions that can then be targeted in different environments, it really makes sense to have WebAssembly be the basis of that. Again, whether it's targeting consumer extension or server-based extension, we lose the concern about having to have native application support.
Right. Yeah, it has very broad applicability. Almost, there's so many systems out there that have developed a community and a user base, and extension can be done with WebAssembly in any of these platforms like Flight Simulator. Wow.
Yeah, absolutely.
All right. Sorry, let me let you carry on.
Sure. So the next use case is one where WebAssembly is just an implementation detail, right? It's not part of the programming model. It's not, you don't even have to think about it necessarily. And that's sort of the basis of where Microsoft is going with Blazor. So Blazor is a way of building applications, like single page applications, and pushing them to either run in the server and render there and then push sort of updates to the browser through a communication channel, or just to push the entire application into the browser with WebAssembly as the basis of the runtime. And of course, the runtime there we're talking about is .NET. So this is basically a .NET application, single page application, running in Firefox on Mac OS. And it'll also run on Chrome on Linux, and it'll also run on Edge in Windows. And if we look at the browser tools and reload the network, what you'll see is a bunch of DLLs.
DLLs.
And the DLLs are running in the browser portably and safely because the Mono platform has been compiled to WebAssembly. And in this case, it's just a detail, right? There's something called the Uno platform that predates WebAssembly, but using technologies like XAML and Xamarin, they allow you to build pixel-perfect applications across Android phones, iPhones, Linux, Windows, Mac OS, and now they're also using WebAssembly as the engine of bringing that same pixel-perfect cross-platform capabilities into the browser as well. So, you know, when people start to learn about WebAssembly, they're thinking, okay, we have to do something new now. But the reality is you often don't, right? It's going to be an enabling technology, whether you realize you're using it or not, but it also allows you to reuse existing code. It allows you to reuse existing applications. And I think this is one of the things that developers are probably going to be the most, I don't know if I want to say unhappy about, but if you think about it, enterprise user interfaces sort of basically had moved to .NET and WinForms and things like that. That was the answer.
Right. Back then.
Until those desktop applications still needed to be installed. And if you're talking about a large corporation, you know, thousands or tens of thousands of installations, that is an enormous piece of effort to roll something like that out. And so I think why enterprise developers have been given the opportunity to pursue JavaScript-based UI frameworks in the last several years was because that installation cost was still so high. And what I think organizations are going to realize now is I can pay C# developers to build applications that will be either desktop applications or in-browser applications, no installation cost. And I think that is going to take away some of the opportunity to use JavaScript frameworks, at least in the enterprise. I'm not saying across the board, but you know, the programming model is easier.
Yeah, I think I'm saying this maybe it's half jokingly, but maybe the hardest thing to change at this point is our understanding, is the fact that our reality has changed and those trade-offs are no longer valid. We can sort of have our cake and eat it too. And the implications of that is something I probably need to process for myself for some time.
Yeah. Now, again, nobody is trying to get rid of these JavaScript frameworks. Things like React and whatnot and Angular have already had portions of themselves rewritten using WebAssembly. Right? There are elements of, like, you know, searching through the virtual DOMs and whatnot that maybe were never all that performant in JavaScript, but by taking advantage of this, you know, they can rewrite portions of themselves and nobody even has to know. Now, keep in mind, we're also in the early days of the optimizations. There have been some recent studies that have shown, you know, WebAssembly generally is faster for certain kinds of activities, but maybe not as much faster as you might think, given how good the V8 and other JavaScript engines are. So again, I don't want to oversell the performance part of it. I think that's going to be a bigger story moving forward. But the performance is also about developer performance and productivity and not having to rewrite stuff, right? So that's part of the story. And then there's the whole concept of code provenance and trust, right?
Right.
I do not trust the typical JavaScript developer without a background in encryption to implement encryption libraries properly. But if I have an existing encryption library built with formal methods by people I trust, then I could just simply recompile it and run it in the browser. And then there's now a provenance to the code that does not, require us to cross our fingers and hope they got it right.
Yeah, it gives you the trust you need. Yeah.
So, in the end, I just want to show two more things, and then we can talk about some other stuff.
Okay.
This is another example of where the web is going in perhaps unexpected ways. It's from a tutorial Google did several years ago at Code.io. But this is an SVG image, and people kind of forget beyond the scale part of the graphic format. It is a hypermedia format, right? And as a hypermedia format, it allows for embedded JavaScript. And in this case, we have an animation sequence that's positioning the sand elements. But the sand elements are being positioned by a physics engine written in C++. So there's a model of gravity. The gravity is pulling the particles down through the shape of the hourglass, as evidenced by the red line there. And that's being done as part of an animation cycle in JavaScript in an image.
Wow.
But these things that are being positioned are DOM elements. So the DOM is being manipulated by a physics engine in real time in the browser. And then we still have the ability to do like animation stuff as well. So I mean, these are the things, like as you said, our reality is changing. Yeah. And really, there's no example of that I think is more proof to me than this last one.
Yeah, what I really like about it is that it scopes, it brings to the fore. It's very clear because it eliminates noise. It just shows you exactly the interaction of those things that run best in sort of their native language environments. If you don't mind going back to it, I took a peek at I ran this on my machine the other day, and you mentioned to me that each one of those was its own DOM element. So I went ahead and brought out developer tools and expanded some of the SVG XML hierarchy, and you could actually see the positions of each of the grains change dynamically. Is it in the inspector? Let's see, what would that be? I guess you'd have to select something. Yeah, let's go ahead and select. Yeah, so there are those positions changing dynamically. And so this is a two-way communication stream essentially, right?
Wow. Absolutely. So the final point that I want to make is my career has largely been lived about 15 to 20 years before the industry, right? 25 years ago, I worked on the first commercial whole earth visualization environment. It was called Edge, from a company called Autometric in Northern Virginia. And we were dealing with terabytes of digital terrain information, hyperspectral imagery, pulling video frames off of Predator drones and warping them in real time to the earth. And at the time, that required Silicon Graphics workstations, right? And within a couple of years, we were able to run that application on a PC with a GPU. And so that's, these are more of my Avengers. Hardware becomes an enabling technology that allows us to change what's possible and the cost of what's possible. And so now, at the time, I started getting into Java in the hot Java days. I was briefly on the Java Advanced Imaging Working Group. But I consider that stuff a toy compared to what we were doing.
Right.
But now we have Google Earth able to run performantly, portably, and safely in the browser. And again, lots going on my machine, but this is pulling in the Google Earth WebAssembly implementation, but it's also the still part of the web, right? And so we can zero in on something and pull stuff out of Wikipedia, or make web calls like we can within the browser, right? And it's not a standalone segmented thing. It is part of the web. And so it's another example of how our whole notion of what the web is and what it could be has been extended and modified. So, this isn't just about the web. This is about the ability for us to extend it and use it, but also to take the code and run it in these heterogeneous environments that are also going to be running our microservices, our serverless functions, moving machine learning into the browser. TensorFlow.js has a WebAssembly backend. It's not that the GPU-based one that's there isn't good enough. It's that allows the same application to be targeted on environments and computers that have decent CPUs, but no hardware acceleration in the form of graphics. So I think that the take-home message of my beautiful mind vision, of which WebAssembly is only part of it, is that our future in our industry is about minimizing the cost of computation. And that's the wall clock time, that's the money time, that's the latency time, right? The time to development. And organizations are going to be able to stop throwing things away and just make progress, and do so in a way that reduces the cost of what it takes to answer a question. And sometimes that's going to mean running stuff in the cloud, and sometimes that means running stuff on a phone, or sometimes it means running it somewhere in between. And so having tools and ecosystems that enable that is going to be a key part of that.
What really blows me away about this is how you prefaced all of these compelling demos by saying this is just the MVP, right? In that the picture is even wider, in that the browser is only one of all of these environments where computing is now sort of making its way into. I know wow, this has been so exciting. So if this is not compel you to look at WebAssembly more closely and these other technologies and these other projects that leverage them and sort of do like the ultimate mashup of whether it's hardware and software and environments, I don't know what will. So that's hopefully give you an idea of some things to look at, maybe. Ways to go from here, of course, is to read up on the technology. There's plenty of projects. I think, Brian, you do a good job. I read your book, finished reading him a couple of weeks ago, and I think that's one of the things that sticks out in my mind is if you're looking for an assembly of projects to dig into and look at, they're all cataloged in your book rather nicely, I'd like to say.
Thank you.
Yeah, I think I'm going to allow our audience to sort of explore your book. And there's one comment I wanted to point out, which I found the organization of the book very innovative and unique in that you sort of force the reader to discover or to replay the evolution of the technology by doing it the hard way first. And then you introduce some advance in the technology that allowed you to no longer work at such a low level and be able to sort of work up that ladder, so to speak. Yeah.
Yeah, I mean, I'm a big fan of understanding things, right? Not just going to Stack Exchange and copying and pasting and not really thinking about things. And so I want people to see how it works, and also then how as you said, the advancements reduce that burden from you, so you don't have to think about it. But I think it's still important to understand the way technologies build up that way. So
yeah, absolutely. Yeah, so I thinking maybe one way for us to maybe close is to sort of bring it back to maybe the relevance of the technology, at least the way it's applied today in the service mesh world, and we're specifically going to look at how WebAssembly was effectively used as a mechanism to extend the behavior of proxy servers in the context of Istio, or maybe just in this case, I think the demo I'll run through is specific to Envoy. It doesn't bring in Istio in the picture. And so one of the things I wanted to point our audience to is a number of resources. If you're interested in seeing how WebAssembly is applied in this context, there is a project called Proxy Wasm. So the idea is some kind of SDK, some kind of extension mechanism, which is, I think this picture does a good job of explaining how this is implemented. On the left-hand side, what you see is this could be a proxy such as Envoy, written in C++, which was sort of instrumented in such a way that it's actually it's the hosting environment for this Proxy Wasm extension. So they embed the Wasm runtime, and essentially through configuration, you're able to load into that environment your own custom modules that run inside the sandbox, which are those blue boxes that you see on the right-hand side. So that's worth, if you want to understand how that works, it's worth exploring that project called Proxy Wasm, which is sort of the gateway to that extensibility mechanism. And then what you have are, again, multiple SDKs that make it even easier for you to implement those modules in different languages, in Rust or C++ or other languages. The one I'm sort of highlighting here is the one that was written by one of our Tetrate employees, Takeshi Yoneda, which is the WebAssembly Wasm SDK for Go for proxies. Yeah, it's called the Proxy Wasm Go SDK. And it's rather surprisingly easy to play with this. So the best way to go about it is to look at the examples. There's a bunch of different examples, and I think one that's maybe simple enough for us to follow along is the one called HTTP headers. And all it really does is when you submit an HTTP request to a proxy, who will then forward the request to a backend, it's sort of capturing the request headers and response headers and displaying them and logging them to the console. That's all it does. And I figured maybe we'd walk our audience through how that's done. It's rather simple and doesn't take much time. I'm just going to go ahead and grab this repository and drop down to a console. And I'm going to go to a little work areas folder and just clone this repository. And if I navigate into this Proxy Wasm Go SDK to the example in question, and I'm going to make this a little bit bigger so that we don't have too much difficulty seeing. There's that README. So there's a couple of things to look at. The first one is, how do you actually tell or configure a proxy such as Envoy to load your Wasm module? So you probably want to take a look at this Envoy YAML file. Now, if you're not familiar with Envoy, this might be a little overwhelming, but I'm going to walk you through it. It basically configures the proxy to run on port 18,000. Proxies are configurable through filter chains, and if you do it at the HTTP level, it's sort of a nested filter chain where you have an HTTP connection manager with its own HTTP filters. You see it there on line 26. And the mechanism is to always put sort of the router filter at the end, and in between this line 26 and that router filter is a declaration of your WebAssembly module. So it's called the Wasm Filter. Right, there is the name of the actual type, and notice here the VM configuration. You actually specify what VM you want. I think there's a couple of alternatives there in terms of what VM you want to use. That's not really very material for our conversation, but here you specify the file that you want to load. In this case, it's going to be a file called main.wasm, which we're about to compile. That's the configuration. So notice that in my directory listing, I've got a main.go file. And if we take a look at it, you get some sort of idea of what that API looks like. So here's a function, for example, called on HTTP stream done at the very bottom there. Here we go. which is going to be called. It's sort of a callback when the proxy server that's running and has your module loaded finishes handling an HTTP request. There are other methods such as on HTTP response headers, when after imagine the HTTP request coming in, the HTTP connection manager parsing all of the information from that stream into a list of headers, and then your callback method is called. And all this piece of Go code does is essentially grab those headers, checks for an error, and then iterates over the headers and just uses a logging API call to use the proxy's logging capabilities to log that to the console. And it does a similar thing with the request headers. So here there's an on HTTP request headers method it's called that does looks like it replaces a header, and then it gets the list of headers and then finally iterates over them and logs them. So the way this works, you actually have to use TinyGo to build this, which is a version of Go that allows you to compile things to using the WASI target. So that's going to create our main.wasm file. So the compilation is done. You see that main.wasm file there, which was referenced in our config file. And then we could just run Envoy. I have a CLI called Funky. If you're not familiar with Funky, let me just go ahead and visit funky.io. It's basically a convenience tool that makes it easy to run Envoy from the terminal. And you can just say run with the configuration file, and that's just going to start our proxy server. So our proxy server is running. And I failed to mention that, maybe I'll open another tab. If we take another look here, what exactly is this proxy, right? So if you look at the routing rules here, it's actually sending things to a backend called web service. And if you look for that backend, you'll see it's defined here. It runs on port 8099. This is how you tell Envoy that you have some backend running on a particular port. Now, the implementation of that backend is actually rather clever. I don't have to start it up. It's actually built in here. There is another listener on port 8099, which is just sending a direct response. You see it right here, which is the body that says example body. So if we were to do a curl on localhost 18,000, you'll see a couple of things. You'll see that request was proxied to that backend. But then you see those log messages coming from our Wasm module, which actually just spit out the requests and responses. So hopefully, for those of you who haven't played with using Wasm to extend an Envoy proxy, this sort of gets you going. I'm going to stop right there. There's much more we can explore. There's a bunch of other examples. And that, I think, was the extent of the demo I wanted to give. Here again is a snapshot of the cover of Brian's book. And maybe the last thing I'd like to mention pertaining to Wasm here is the fact that my colleague Peter has actually put together a whole workshop with a list of labs that you can run on your own. This is free and available online, that will walk you through sort of an end-to-end workshop on WebAssembly for Envoy and Istio. What else? Let me just close with a few sort of orders of business, things to look forward to in terms of future episodes. These we run weekly. Our next episode will be next Friday, where we discuss Envoy and Kafka, which is a really interesting intersection. We're going to have a guest by the name of Adam Kotwazinski, who works at Workday. Workday is a company that's adopted Service Mesh. You may know that the Istio YouTube channel has a talk by another Workday employee on how they use Istio and how they've optimized it to run in production. So we look forward to that. May 20th will be the last day of KubeCon EU, and I'm thinking maybe we'll do a KubeCon report for May 20. And then finally, again, a reminder about the Tetrate Istio certification exam. The Certified Istio Administrator by Tetrate, that's the official name, CIAT, is available. So if you've got your Kubernetes certifications and looking to sort of expand upon that base, that certification is available on our Tetrate Academy, which I'll just go ahead and show you the landing page for it right there. And finally, this is probably maybe the most important part. Join the conversation. We've got a Tetrate Slack community channel with literally a direct access to all our engineers. So if you have questions, and even obtuse questions about the minutia of the implementation of whether it's Envoy or Istio, a lot of the Tetrate engineers are actually committers on those projects. And so that's a resource you should not hesitate to avail yourself of. And that is it. So we're going to go ahead and close this episode, close the conversation. And again, thank Brian for such a compelling demonstration, for coming on.
Thank you.
I was really blown away.
I think the most important thing for people to take away from this is it's about productivity and it's about keeping you safe. So.
Oh, I love it. Short and to the point. Well, thanks, everyone. And we'll see you next week in our next episode. Bye-bye.